a philosophy. Amatram akshar nasti, nasti morma noshadam, ayogya purusha nasti, yoja kasra durlabh. This shloka means there is not a word which cannot become a spell. There is not a plant which cannot become a medicine. Also, there is no person who is useless or can't do anything. Only the yojak, he is rare. Pedagogies. So in STEAM Varsity, we promote these pedagogies to create this a culture, not a course. So here we use learning by doing, peer learning, peer mentoring, mixed age learning, and most important of them all, learning from failure and even celebrating the failures. Now I would like to invite our chief guest to take over this session.
Thank you. Thank you, kids. Will you confirm to me I'm audible and proper, loud and clear?
Yes, sir, you're audible.
I'm very thankful to kids, uh, especially on the Sunday when you are deserved to take rest. You are eligible to take rest. Okay, you are being pulled to listen to scientists that too lots of technical stuff, which is very heavy. I'm sorry, we are encroaching into your entertainment domain, but nevertheless, because this day is very important for us for the India, and you in the generation who have seen such kind of wonderful victories when nation is competing with the world, I think it is you deserve to spend some time encroaching into your freedom of your holiday. Okay, so with that note, probably I will jump into some presentation so that you will enjoy the slides while I was talking, not getting bored to look at my face. Hey, can you just confirm someone that my slides are visible?
Yes, sir, it's visible.
Very good, very good. So I've chosen a topic, space 2, because so far the Indian Space Research Organization was rather leading the space program in the country, and now a transformation took place. The government is very keen in increasing the space footfall in the country, and they expect the space industry and space domain should extend these arms to global. So that's why lots of reforms have come. Government expectations are very high. And more, the ecosystem builders like you people, including you people, have got lots of expectations in the space. That is why I took the name of Space 2.0. Today, you have seen around the world, whenever you switch on your mobile or your Facebook, your updates, your, let us say, X or your Instagram or your TV, fighting, fighting, fighting. Am I not? Some are economic wars, tariffs, reactions of different countries, trade wars, wars for protecting their sovereignty one side, wars for encroaching others' domain on the other side. The oil diplomacy, oil fighting, natural resources, hidden agenda for many countries to explore the pondering the natural assets of other countries and having dominance on them. So what all these things calls for? Why? How others will come to know that there are natural resources elsewhere, so that if we can encourage the country, we will be wealthy. On the other hand, there are lots of issues, social issues, economic issues, environmental issues like drought, overmining, forest fires, depletion of water, depletion of groundwater, drought. There is no proper for what you call rain at sometimes, and there is a huge rain which causes floods in that region, pollution, solid waste management, where they have plastic management, urbanization. All these things are causing lots of disturbances to the conventional organic life, conventional life. In addition to that, sovereignty protection, cyber issues, so many things, because one has to look for survival. If it is not feasible for those intelligent students, they put their perspective into the negative connotation. So that is how these lots of things are happening, looting, let us say financial crimes, all these things are happening because there is a huge economic and geological imbalance in the system, in the overall system. So for that one, what do we do? The technology only, the driving force, the technology for detecting the frauds, the technology for detecting the what you call crime, the technology for detecting the resources, the technology to detect the to conserve the resources. I'm not telling that the space will provide solution for all, but space will be a catalyst, or space will be a tool, or space will be an enabler, or space could be an analyzer for creating or for showing a roadmap or for showing some kind of hopeful solutions for many problems. For many problems, it could be a pollution, or it could be life saving for cyclones, or it could be water resource management, groundwater resource identification, could be renewable energy, where the solar power is more to establish the solar power stations, smart cities, how urbanization is going to happen, how to manage a let us say big colonies, big cities, how to drive the drinking water management, how to plan a wastewater management. For many things, the space could be a choice. That is where the space is becoming the fourth dimension for economic growth. That is why yesterday, day before yesterday, we had in Delhi, as a part of the National Space Day, there is a big event. There is a very big event where more than 60 to 70 ministries, they were together, all highest level of officials in the country. They spent a couple of hours to sit and discuss how the space will be helpful for economic development and social development of the country. You just imagine, when such kind of event has happened in Delhi, how much importance the entire government, the entire country is giving the importance to the space. Let us jump into the why should we have space? Because space is not your let us say amusement. Space is not alone looking at the rockets, looking at the astronomy, looking at the your fascinations. But 70 to 80% of the entire requirement of the space for meeting the social needs and social requirements and your own needs, you are not visualizing. This is the seminars, this kind of webinars and seminars are meant for creating an awareness why space is required, why space is essential, why space is only the tool for your economic growth. So once you aware what the space is doing for you, helping you, then you will start generating your own passions and your own curiosity and your own interest to pursue the space as a career, as space as a tool for your career building in the rest of the life. Space predominantly can be bifurcated into application-wise, remote sensing, communication, navigation, defense applications, something like that. Let us concentrate something on these things, how these technologies will help us. If you say satellite is sitting on the top, what it does, only many people will be knowing for mobile applications or for a TV. Yes, they're all true. But there are different kinds of satellites, optical payloads that are there in the sitting in the low Earth orbits, which will control your water movements, your let us say how actually the traffic is moving on the earth, so that they can make the dynamic signaling there to try to divert the traffic congestions. Glacier, how actually they are melting and becoming the waters and creating the floods, ongoing floods, so that people will be averted. The agriculture, food security, when something is happening in UP, a huge amount of produce is happening. If you don't proper planning, logistics to take that excess food items to the rest of the country, what happens? There is a surplus and they have to throw into the dustbin. So let us say whether it is a piyaz or whether it is an aloo, you should have proper system of understanding how this crop is going to come in another 1 month time or 2 months time and 3 months time. You have to plan properly all the logistics, whether it is trucks or trains or storage units or cold storages, so that rest of the country where they are not produced will still get that food items. One thing is, at cheaper costs and at reliable reasonable costs, you are getting food items. Second thing, there would not be any waste and surplus, so that the farmers will have to throw those items without selling, without having a market. Pollution. Now you are seeing Delhi is about 2 to 3 months in a year always faces traffic congestions, your restrictions on the traffic movement, vehicle movement. What for? Because of pollution. If you can anticipate what these causes pollution, so much pollution, maybe agricultural fires, or maybe you are wasting. You are seen using the space technology, the actually hours when the farmers are firing the agricultural let us say waste have been tracked and fined, so that the pollution is in a position to control. So for all these things, the geospatial information, lots of satellites are there across the globe. They are watching the satellite, they are taking images, and these images are being processed. And GS market, if you see, whatever you are seeing today, GNSS, what you call it as positioning system, that is creating huge amount of market. Let us spend some time on how actually these kind of images are going to happen. This, I think you have heard multispectral and hyperspectral image processing and this thing. What it does? It does the images of the earth will be analyzed in different forms. And let us say you have a let us say coconut plantation along the borders of an agriculture paddy. You can see, all of you please mute. All of you please mute. All of you please mute. Organizers, please ensure that all the participants will mute. Okay. With these coloring, based on the coloring, what we will do, we will understand what is the kind of crop. Let's say everything looks green, whether it is paddy or whether it is a plantation or whether it is vegetable crops, all looks like green. If you take one single color image, you can't find out whether it is a coconut plantation or it is a paddy or it is some other vegetable or it is some flowers. So these multispectral, what it does is different bands, the color will be distinguished, and you will find out even within the greenery what kind of green is representing one crop, what another color is representing another crop. So this is called image processing. One, you have a best career in the image processing techniques. Those who are graduates, please try to get into this, acquire these skills to pursue your career. Then the cloud, when the satellite is going around the earth, what happens when the cloud is there on the top? They cannot go through the clouds. Image optical instruments cannot penetrate through the clouds. So when rainy season is there, how to monitor our earth? This is a big challenge for us. Then there is a technique, SAR, synthetic aperture radar technique, where the microwave waves will penetrate through even through clouds and take the image of the earth. So when you superimpose this particular SAR images with the optical image, this is a technique called fusion. Now many companies are working on this. You will get 24/7 map of the earth. So the SAR is one technique, and optical image is another technique to map the earth to get 24/7 images. So what these images will do for us? How the geospatial market is? When you are building, let us say you have seen lots of towers in all cities. What happens? One tower consumes the power equivalent to one big colony. Let us say in your in your village or in your town, there is a big colony where 1,000 houses or 2,000 houses are there, families are living. You'll be using normal power. Whereas these business towers, what happens out of their release, out of their illumination, out of their let us say extra kind of electrical appliances, consumes huge amount of power, which creates lot of demand on the power. Rather than generating the power, it is better to conserve the power. So the technology, what it does, they are creating a computer digital twins, what we call it as, and mapping all these power requirement devices, and you are sitting in your own house and switching off whenever there is a corridor, let us say, nobody is moving. Why power lights are required? There is a lift, some kind of rooms where people are not there, so automatically these sensors will stop or will put off the power. Even that sensors are not happening, the people who are operating this entire digital twins can do so, so that power can be consumed. The technology has gone to this level where the IoT, the sensor, for all these things you can use terrestrial and satellite information. So to connect, let us say somebody were telling Bangalore, my office, I am able to operate from Singapore. How that is possible? There is no connection, there is no telephone, there is no wires connected. This all will happen. There is using a different technology, we call it as IoT, which are based on the satellite technology. Similarly, the same thing I was telling, information, building information modeling, infrastructure management. When somebody is sitting in USA, they are able to manage the construction projects of, let us say, Middle East or Africa, South America, South Africa. Agriculture is an important aspect of the satellite monitoring. You are in a position to identify the moisture of a soil, fertility of a soil, because of lots of data available, ground data is available, and you are able to predict how much rainwater or how much surface water is required to cultivate this plant. So earlier, when the huge amount of water used to be there in your fathers and mothers and your dadis and nanis will be telling you what they do when water comes. They'll just open the gates and the field will be full of water. What happens? The crop takes only less than 10% of the water, 10% of the water, and rest of the things will be evaporated. Okay. So to curtail that one, what happens? To curtail that one, these technologies will assess, and ultimately you can assess how much water is required for that ground. Yeah. Okay. So there is a forest. The forest deforestation is creating lots of problems for the atmosphere imbalance, ecological imbalance. When forest is getting depleted, and new forestation has to be done to balance the carbon. So how much deforestation is happening on account of fires, on account of deforestation, the satellite picture images tells us. And every 2 years, the India, there is a rule that every 2 years, or there is an understanding that every 2 years, we do complete mapping of the forestry and identify how much forest we have lost. That only happens using the satellites. So when it comes to the SATCOM, the number of usages are enormous. You are using mobile, using satellite connectivity and terrestrial network. You are using OTT platforms for entertainment. You are using broadband. How this I am able to connect with you? Because of the internet connectivity, which is of the satellite. Otherwise, it is never used to be there. If one has to come to you and start explaining, is it possible? No, never possible. Distress alarming system. When somebody go into the fishermen going into the international waters, what it used to happen? Unknowingly they cross the international boundaries, or unknowingly they will enter into the other domains. Then those police will come and arrest them and they will take them. There will be diplomatic discussions to bring back our fishermen. Now, there is a district alarm system. When they cross our boundaries or when they are entering into the neighboring boundaries, there is an alarm. The satellite gives the fishermen, oh, you are entering into the international waters of others, please come back. So they will come back. So there is a lives are, the fishermen who are not connected with the terrestrial network, their lives are being saved. The symmetry weather systems, automatic weather systems are getting connected. So these are all satcom applications which satellite is doing. The navigation is there is a sky is only the sky is not even the limit for navigation systems. Still, we are working, we are penetrating this navigation system. When you wanted to have some kind of let's say internet connectivity in flight, in flights you never have used to have connectivity. You cannot once take off, you'll go to the airplane mode, but still using the satellites you can have connectivity. You can still talk to the people on the ground. When you are ordering Zomato or when you are ordering some Swiggy, you can still track where the item would be using navigation. When you wanted to go from one place to another, if no guide is there, this is the guide, Guru positioning system, geo positioning system. Somebody said Guru positioning system. So these are all the technological applications what satellites gives us and makes our life very simple and comfortable. So don't you think that when you have these technologies, so different people will have different ways of handling it. Let us say there is an Uber. Uber will have their payment system also linked to the distance that is covered. So they can have their own satellite constellation, so that they can depend on their own satellite constellation. So that is the technology leverage they are giving. There is a new concept. It's not new concept. It is a emerging concept, quantum technologies. What happens when we do lots of communication? There is a chance that the other people can trap. This is called the hacking or the what you call spoofing, something like that. So when you have your secured communication, when you are talking, let us say somebody can trap your phone and listen to you. That's what the people are complaining. So when you have a secured communication, these problems will be avoided. These problems will be avoided. So hence a quantum technologies are now becoming very active to protect the interests of the people and security of the nations. And these are all the areas for you people to pursue, maybe down 10 years down the line or 5 years down the line. These technologies are becoming very prominent, so that you should start thinking about these technologies, so that by the time you come to your graduation or by the time you come to your career building, these technologies will be handy. Right now, you have your roadmap to be built. Please make your roadmap. Okay. So what we have achieved so far. Just give me 1 minute. I'll just come back to you. There is an urgent call. Okay, fine. So far what we have done, see, our scientists are very prominent scientists. The most critical science missions we have done in the first moment itself. In the first moment itself. Be it Mangalyaan, be it Chandrayaan 1 and 2 or 3, subsequently 3, we have done it. We have become the first country to place our spacecraft near the South Pole, which other nations could not do. And at the same time, you have seen the Russian mission, the Japanese mission, the US private mission, when they have failed. When such a kind of feat was achieved by us, you just imagine how the pride the nation takes in the global scenario, global technological scenario. That is why we are celebrating yesterday the National Space Day. And Chandrayaan 3 is going to be the target sector for us. For this will become a base station, or it will become a base point for us to escalate ourselves in the space. Now we have huge amount of expectations from the government and the country to have many more such missions. Aditya mission, when something is happening in the solar, even though solar sun is a god for us and is just giving huge amount of energies, but there are some disadvantages out of the solar flares. So we have sent an Aditya mission so that it will preempt us with the solar emissions, the coronal mass emissions or solar flares, and protect our space assets and protect our own, let us say, sensitive systems on the ground. We have achieved such kind of missions. That means technologically India is not inferior, rather superior or on par with any global standards. But only thing is, we require some kind of direction and some kind of clearances, so that we can meet or we can reach anything. So for doing this, lots of technologies have been developed within the country. Probably none of you would have an opportunity to see. I just, my intention is to show how big the items that we create to build the rockets and satellites. These are all engines. No country except for those 4 or 5 countries have got this kind of deep technology prowess to build any kind of engine. Now, yesterday, Secretary Department of Space Chairman ISRO has announced that the space semi-cryo engine and semi-cryo stage is going to fly soon, which will increase our capability from 4 tons to 6 tons to the geo orbit. And that is going to create another major milestone in our launch vehicle capability. There is an 85-ton liftoff vehicle, which we call it as LMLV, which I could not capture some of the slides yesterday, what has been projected. The LMLV is a 3 times bigger the vehicle that compared to our GSLV Mark III, and that is going to create a history in the Indian space research. And we have lots of ground systems, solid propellant plants, which produces the solid propellant, and these are all ground tested before inducting into the stage. These are all positioned in SDSC SHAR as a part of the launch pad, because solid motors of 200 to 250 tons we cannot fly on the roads because of the safety. We have liquid systems propellants, which will be tested near the Mahendragiri, near the Kanyakumari. The semi-cryo and locksmith engine are going to be tested in some of these test stands or new test stands. So this much infrastructure has been created within ISRO to meet. It is not just like that rockets are flying. There are huge amount of infrastructure that is rather not access to the public, because these are very highly secured regions. We have launch port. 2 launch ports are there within Sriharikota Island, and the third launch port is going to come for a small satellite launch vehicle near Mahendragiri, near Kulashekharapatnam, near Kanyakumari. And we have got lots of radar stations across the country and around the globe to track our satellites and rockets. And we have capabilities to track the debris. This is multi-object tracking radar, which was conceived, which was commissioned 10 years back. Now the advanced systems are going to come out, and these things will track small even 10 centimeters debris and protect our satellites in the sky. Huge amount of control systems, control rooms, control centers, where the scientists will be sitting 24/7 and watching all the activities across the globe. And see, these are all the things which the satellite facilities, the satellite manufacturing is a very crucial and precision requirement of the country. Even a smallest wire cut cause catastrophe for the satellite failure. So many tests we have to do, because when it is going into the extreme environment, it may undergo lots of radiations, it may undergo lots of acoustics. These tests have to be done. And ultimately, when the thermovac has been done, then the satellite will be put into the heat shield of the satellite. So what is next? So far we have achieved, so far we have done. So yesterday we have announced the roadmap for 2047 Viksit Bharat. In that one, we are going to have huge amount of launch vehicle upgradations, which will carry up to 75 to 85 tons to the lunar orbit. There is a roadmap up to 47. Initially, we'll have NGLV, which is a new generation launch vehicle, which will carry 10 to 15 tons to the GEO, because which will primarily will be used for Gaganyaan as well as Bharatiya Antariksha Station module buildup. After that, man on the moon, we have to have, for such kind of things, we should have bigger launch vehicles. Chandrayaan 4 is on anvil. Bharatiya Antariksha Station is on anvil. These are all the different launch vehicles that we are thinking. So for that one, air-breathing engines, vertical takeoff and vertical landing provisions and capabilities we have to build. Reusable technologies we have to build. There is a huge roadmap in front of ISRO, ISRO scientists, because this is the second generation. That is the reason I said for last 50 to 60 years we have been doing in an organic way. Now we have to get into the inorganic method of building our capability to reach our targets and to catch up the pace with which the world is going. The new space agency, the startups, the new private companies are going. And obviously the Gaganyaan, I missed talking about the Gaganyaan. Gaganyaan is on the final wedge of conclusion. Many technologies, you do not know how many thousands of technologies need to be qualified, whether it is environment life support system or space suit or sensors or environment or let's say parachute systems or pad abort systems. So many systems need to be qualified before we attempt this unmanned and manned cruise. It takes huge amount of time for developing, understanding the systems, developing, qualifying, and testing. So it is not a simple job. People may think that people will sit in a crew module and that will go into the space and come back. It is not so simple. When it is failed, what will happen? At each and every step, when it is failed, what is the option B? We have to think and we have to incorporate in the system. Test it. It is not enough to test it. We don't have ground systems to test it. We are depending on some of the foreign agencies. They are helping us, but ultimately we have to be self-reliant and we have to have our own independent system where the other countries will come to us and avail our facilities. That is how Atmanirbharata, self-reliance, is playing a big role in all this technology development. And obviously you are the people who have to come dream today or develop a passion today, pursue tomorrow, and become resources day after tomorrow. That is why when the kids of 8th, 9th, 10th standard, they have to get to know all these developments, what is happening around the world. And they should dream it. I want to become a space scientist. I want to become a space entrepreneur. I want to become a space user. Today, if you say all 140 crore people are using the space technology in one form or other, you can be a user to create demand for the space industry. Okay, I wish that I think I have taken a reasonable amount of time to explain you what kind of technologies, what kind of roadmap we have. Last, I will close with the space situational awareness. So whatever the every year now, 25 to 26 thousands of satellites are going into the Leo market, Leo's domain. So what will happen to the satellites? There is a big question. So they may collide each other. They may collide the dead debris, the dead satellite, the depth stages may collide with active satellites. So the space traffic management is the one which is becoming a crucial thing. When you create a traffic, creating traffic is a huge task, but clearing the traffic is also a huge task. So this is becoming another $1 billion or billions-dollar business. Whoever cleans the debris, they are going to they are going to become protectors of the space. So this in this angle also lots of research is happening. And of course the deep space missions, it requires to reach Mars. You cannot go on conventional flights. If you go, it takes months, years together. You have to have hypersonic aviation so that with a 10 Mach number, 15 Mach number, when you go within a reasonable time, you will do the interplanetary travel. Okay. So ultimately the careers in space, yes, what for careers in space we are doing? See, for carrying something our life simple, one thing. Second thing is we have to pursue our employment, pursue our research, pursue our passions. We have to pass time with self-sustainability. So for that one, you have lots of activities are there, lots of avenues are there to get into the space domain. Those who are graduates, they'll go into the different let us say centers of ISRO. Fine, if ISRO cannot accommodate, all the people cannot be accommodated. There are lots of industries, there are lots of academia where you can get associate yourself and you can start your own industry or you can start your own career. There are CEOs, COOs, CTOs are available today. Hundreds of people they are generating the revenue and still in the space domain. So what is the social responsibility? For that one, people like us, reach out to the people, and we have created around 150 space tutors. Is a continuous program, and one of your university is also space tutor. That is how they are getting connected. We create the awareness. We try to create the spirit and interest amongst you people to pursue this career. Get to know what is the advantages. And if you want to know something more, you just get into the ISRO website. There are two icons, as I was showing here, ISRO portals. Please get into ISRO STEM and Spark. These are all the two icons which will take you to different sites where huge amount of documentation, videos, photos, images, everything is there. ISRO STEM talks about a career, what you can do, a online certification, just similar to Yuvika, because all the material that is used for Yuvika, we have posted in the Shiksha Gagan portal. If you log into this portal, you can go through this exercise. 26 chapters are there that will teach you the basics of space science and technology. And at the end of the day, when you ask the questions during the course, it will give you a digital certificate also, as if you have completed. So there is no deprival that you have not been selected for Yuvika. The same thing in an indirect way, you will get it. Yes, lots of engagements are going on across the country. There are internships, the science fairs are happening, online competitions are happening, young scientist program happening. Olympiad has happened. Astronomy Olympiad recently we have concluded because lots of winners are there. You make yourself aware what is happening around the country through any means. Hackathons are happening, student projects are happening, visits are happening. Okay, there is a science space on wheels which was created by me, going around the country at various places. You please get to know. There are a number of opportunities to get to know what the technology offers you, what the technology brings you. And ultimately, the idea is you will become one startup one day or other, or become a space entrepreneur or space employee or space user, so that you will contribute to the economy of the country, social development of the country. And when we do such kind of outreach programs, this is the footfall. How many children? Thousands, lakhs, not even thousands, crores, I should say. Millions of children, they have benefited out of it. They have listened to the space scientists. They got to know. This department, ISRO and space, is doing amazing job in the outreach. I don't think any other department is doing the way ISRO is doing to reach out to the students and getting the student community getting benefited out of it. And thank you for your patient listening. Maybe if some kind of the question answer session is there, if the time permits, I would be very happy to listen and answer your questions. Thank you.
Thank you so much, sir, for taking such an insightful journey through India's space achievements. The way you connected satellites, navigation, satellite communication, and even the emerging field of quantum space technology has given us a deeper appreciation of how ISRO is shaping not just the future of space, but also our everyday lives of here on Earth. Listening to you, we are reminded that ISRO's story is not about rockets and mission. It's about vision, innovation, and the courage to attempt what seemed impossible. Your words today have not only informed us, but also inspired us to imagine how each of us can contribute to this journey. And now, the most exciting part of our interactive chat with you, sir. So, whoever, this is an opportunity to ask questions, everybody, clear your doubts, and most importantly, fuel your imagination. As we all know, a curious question is the first step to great discovery. So don't hold back. Let your curiosity fly as high as the rockets we dreamed of. So anyone who has a doubt can raise their hands and I'll take you.
So basically, sir, there was just one question. I think I'm audible to everyone, right? Okay. So first of all, sir, thank you for this amazing, insightful session, sir. I'm really glad that I joined and I was able to, meet you out in person and have this wonderful session with you. So my simple question was that what are the qualities and skills should a student, not just from engineering background, but from other backgrounds as well, like biology or economics or design, should focus on to get connected and have a collaboration with ISRO?
See, if you touch about, because the Gaganyaan mission, when you see, especially, let's say come to the first question. See, what are the domains? The space is not an exclusive science or engineering. Okay, if you say what is exclusive for space, probably remote sensing, I should say only exclusive thing for space, because image processing and other things are there. But otherwise, the chemical engineering, the mechanical engineering for structures, the electrical and electronics engineering for different instrument avionics that are required for spacecraft and satellites, the communication engineering, deep space communication engineering, whether it is RF science or whether it's microwave engineering or let us say any kind of electronics and communication engineering, it requires lots of kind of let us say technologies that are adapted for satellite communication and tracking and telemetry. You have let us say material science and chemical engineering, deep space chemical engineering is required for developing where many space qualified materials. Okay, so if you see the space requires including civil engineering, including your what you call the bioengineering. Every engineering takes part in space. Okay, and today especially when you talk about the Gaganyaan requirement ISS, what is happening in ISS? You are making how the artificial organs are going to be made, how unconventional or inorganic agriculture development will take place, how a bone decay can be accelerated or decelerated, or bone formation can be done. So what happens is on the ground, because of the gravitational problems, if something happens in 10 days, exaggerated way I'm telling you, it's not exactly, don't take it as a true engineering thing. When something happens on the earth, let us say 10 days, if you take it to the microgravity, you can do it in 1 day on an exaggerated manner. So that means accelerated testing you can do in microgravity. So that, in fact, the experiments what has been done, what I have shown, there's a NASA, there is a beautiful documents available. What ISS does, there are 8 to 9 documents are available, which I have shown in my presentation. Please go through them, get to understand what kind of experiments we can do in space, so that we can do experiment in the space. That formula or that technology, we can bring it back to the Earth. So that gives a leverage for us. Whatever we have done in 1 hour or 1 day or 1 month in the space, when you bring it back to the Earth, it will happen. Maybe it may take some more time.
Thank you so much, sir, for your answer. We have a lot of doubts lined up. So I think we can take one from SDVM. Right. So please go ahead.
A very good morning, sir.
Morning,
Hello,
morning.
sir.
Please go ahead.
Sir, I have a question that what can be the minimum mass of a rocket?
What is the minimum mass of the rocket? If you want to play with a rocket, it can be 10 grams, but it will not fly. It will be on your desktop as a showcase. There is nothing like that. The minimum, what is the, you can ask what is the maximum rocket? There is a meaning. What is the minimum mass? I could not understand your question.
Um,
What is the minimum mass of the rocket? What do you want? Okay, fine. I'll put it in this way. Okay. See,
means
any rocket, the mass will be decided based on your mission. Okay. Some are weather rockets, some are suborbital rockets, some are LEO rockets, some are GEO rockets, some are deep space mission rockets. Okay. If you want to do suborbital mission means a small mission which will go to 100 kilometers and come back, less than 100 kilometers and come back, which are basically for weather studies. It could be somewhere around, I should say, 4 ton to 5 ton. Okay. If it is orbital rockets, based on the let us say the satellite that you require to carry, let's say to carry 500 kg satellites, what happens? 100 tons may be roughly required. Okay. If you want to carry 10 kg satellites, maybe 20 tons rocket is required. For carrying 4 tons satellite, GSLV Mark 3, if you say 640 tons satellite rocket is required. Okay. If you want to take the same thing to LEO, if GEO, if it carries 4 ton, the same 640 ton rocket, for LEO, it will lift more than 10 tons or 8 tons. If it is for deep space missions, if it has to carry 4-ton rocket, it requires almost, I should say, 2000 tons. Instead of 640, it has to go directly to the moon's orbit. It requires such a huge rockets. That's why we are going for heavy rockets. Okay. So this all depends on the mission that you carry. There is no straight answer for your question, but you have to work reverse way. You have to work.
Next, maybe we can have Sachin.
Good morning, sir. I would like to ask you something. Sir, we often heard about India making huge strides in space technology, but I'm really curious. Are there still some critical technology we are really on imports? And if yes, what step are we taken to make this technology fully Indians?
See, we are more depending on the electronics. Okay, if you call it as atomic clocks, even though we have done the indigenization of atomic clocks, the transponders, the amplifiers, okay, many electronics items still are being imported. Okay, it is not that we are incapable of doing that one. It is not that one, but it is called economy of scales. Because if you wanted to do those things, what happens is huge infrastructure is required, whether it is industry or ISRO. It is something like that, making a big mansion for carrying one marriage. Will you do that one? You won't do. You will go and hire it. Let's say once in a lifetime, your brother or your uncle is getting married. For that one, are you creating any marriage hall? No. If let us say if it is a business for you to conduct the events, then you will construct a big infrastructure. So similar way, industry thinks if good number of business is there, they will do it because space requires very few numbers. If you want to create the infrastructure which is running into hundreds and thousands of crores to make even one item, it is not economical. So that is the reason we depend on the foreign sources. That is one reason. The second thing is technology development. Yes, if the requirement and business is there, technology development follows. So that is what today it is happening. When the doors are opened for the global business space sector, now everybody is now having an eye. So many startups have come up and building the technologies and building the infrastructure because there is a business, there is a revenue.
Sir, I'd like to ask a question. So there are a lot of talks about digital twins and creating virtual replicas of rockets, spacecrafts, and even missions before they're launched. So are rockets in ISRO also being digital twinned before they are being, sent to space? And is that helping in designing safety and cost if that's happening?
See, digital twin is a technology where a small component or a small functionality can be done in a simulation manner and control it. See, rockets are not such kind of infrastructure where you can control it, you can do it using digital twin on a real-time basis. Okay, this is, let's say, a structure you are making. The
Yes.
structure, whatever you are making, will undergo the design well in advance, and that will be qualified, ground tested. The drawings will be frozen, and it is released for fabrication. Whether it is a propellant formulation is well understood, and they will go into continuous production. Okay, so digital twins are major required for online control, real-time control. Okay, so the rockets, the functionality of rocket facility can be digital twinned, but rocket per se not required to be digital twinned. Maybe a functionality of the simulation we will do, but the simulation we will do for a development of a component or a system which is required to be monitored. Okay, so for such kind of things only digital twin is applicable. But for explaining what is the rocket functionality, yes, digital twins are possible, which will be used for AR, VR, or training purposes. Okay.
Okay, thank you so much, sir. Can we have Akhand? Akhand?
Yes. So my question is that we have heard about the postpone of the launch date of mission Gaganyaan. Is there any technical problem in the spacecraft, or why is it the date of launch is postponed?
Very good question. Why it is you are questioning the ability of the ISRO? Is it? I'm very happy. See, that's what I was telling you. The technology development, okay, it is a very long-term process. What happened? You developed something. When you start using it, it is broken. What do? You'll go back and redesign and do the same thing. Correct? You are repairing your cycle. Let us say. So when you have started cycling it, again the problem has happened. What do? You will go dismantle everything and redo. Okay. So the technology development process, it is not, we are not gods. Each the technology will be created just like that. First we have to develop something, we have to test it. During the testing, if any anomalies are formed, we have to go back to the design stage, correct that one, and come back and redo the testing. And since these are all not available just like that supermarket, we have to design from the scratch. If some kind of understanding is not there, why we have sent one astronaut to the ISS to get to know many other features which we do not know. So when he comes back and tells that these features are there, then our designs we will fine tune or will modify, we will redo. Okay. When a sensor is to be developed, let's say there are 25 different gases needs to be monitored, and each and every gas requires a sensor. For that sensor development, let us say when you are testing it, it has not happened. What do? You should go back. These iterative cycles, which is not expected, which is not possible to expect, will cause technology development research cycle long. Even though our intention would be, yes, we will do it in 5 years. What happened? COVID has killed us. Almost 2 to 3 years, the technology, the people, there are a number of disruptions have happened in the supply chain, in the global supply chain. There are many reasons for these delays. Okay, it cannot be attributable alone for the facilities. So when they are all done, our question should be like Operation Sindoor. When somebody asked how many of our planes have been grounded, the best question could have been whether we have succeeded or not. Okay, whether we are in the right path or not. When once ISRO completes the technology, that technology will be robust, foolproof, fail-proof, and sustainable. Okay, we should all work for a successful Gaganyaan mission, and these are all man-made missions. World is looking at us. If it is failed in the first instance or this thing, obviously the world look at us in a different way. Delay is not the main criteria. Success is the main criteria. In that way, the ISRO is forwarding. Okay. Yes, you have a right to ask why it is getting delayed. So these are all the answers for the delay.
Thank you, sir. Rudra, you can go ahead.
Sir, can we use a rocket many times?
Oh, sorry, I'm muted. A rocket which is used multiple times is called reusable rocket. Okay. So for that one, we have to get back the rocket. See, rocket will go up. So when we will reuse the rocket, when we are able to capture it back. Okay, you are understanding my point. So what happens? Rockets are made out of different stages. These stages for deep space exploration are LEO 400 kilometer or 500 kilometer orbits. When the rocket goes and injects the satellite, it will cross many of the stages, upper stages, crosses the atmosphere. That means it will go to 400, 500 kilometers. If any stage, lower stages, which are fired and expended below, let us say, 100 kilometers, they can come back and fall in the sea. those stages, upper stages, which will go beyond, let us say 250 or 300 kilometers, it takes enormous amount of time to come back onto the earth. Whether it will not fall so easily, it will take months or years together. So what happens is, for all ISS, which is maybe at a 400 kilometers, when the stage is the lower stages are going up to 100 kilometers or so, they can come back, they can be reused. So that is why full rocket cannot be reused. The stages which will come back, which will not be destroyed during the atmosphere re-entry, which can come back, can be reused. Whereas the upper stages, which will take the satellites into the much higher altitudes, cannot come back so soon. They cannot be reused. So these stages we are calling as reusable technology. Yes, the lower stages, which will take the rocket crosses the atmosphere, requires lots of thrust and lots of fuel and heavy in size. So they contribute to almost 40 to 50% of the rocket value, or 40 to 50% of the rocket value. They can be recovered and reused.
Thank you so much, sir. From Usha Kiran, can we have anyone who have any query? You can go ahead.
Hello, sir. So I had this question related to the emerging technologies that we have. So my question is, how currently AI and machine learning is being used at ISRO and the space missions? And what is the future scope like of AI and machine learning? Where can we use it? Where exactly can we use it in the space missions?
See, AI, ML, deep learning techniques, all these things are techniques. Okay. And wherever huge amount of data and huge amount of analysis, let's say big data analytics, or a huge amount of analysis has to happen on various iterations, these techniques are used. Okay. So especially I should say, let's say edge computing, where it is applicable, you have to filter use of the edge computing itself says that you need not have to search for huge amount of data. I'll take one example. When a remote sensing satellite is taking lakhs and crores of images in one pass, let's say it is covering oceans, which we of not interest for us. It is covering clouds, earth where clouds are there. You see, if it is an optical image, we don't require such kind of data. When 1 terabyte of data, let us say it is pumping it to the ground, how much sources of capturing the data, whether it is cloud or servers or high performance, let us say computation systems, so much 70 to 80% of useless data will be there, which we don't require. Such data, why the satellite should transmit to? Because it requires power, it requires life of that particular subsystem will get consumed. So we are using edge computing techniques in the satellite so that this unwanted data will not reach the earth and our ground stations will not be loaded. And when it comes, huge amount of data comes onto the earth. Let us say we want to analyze a particular herb is there, which is very, very difficult to locate on the ground, but it is very much required for kidney treatment, let us say. So there's a huge amount of optical images available. As I was telling, let us say hyperspectral images are available. Let us say 10 terabytes of data is available where you want only 1 GB or 100 MB. What do? You have to test each and every image against an intelligence by computer. That is where you can apply your deep learning techniques and artificial intelligence techniques, so that these techniques are more used in the applications. Some are we are using, let us say, self-healing. When the trouble is there in the satellite, so you need not have to, there is no possible for you to go and repair, it is not in a car or automobile. What it does all probable failures, we will pre-program it, apply our artificial intelligence technique for a decision making, onboard decision making, and put it in the software, onboard software or OPC software, so that when let us say a reaction wheel is frozen, it has to set it back. We'll apply the technique so that the satellite will take its own autonomous decisions based on the artificial intelligence to get back to the original position. There are a number of applications are there. If you talk like this, it will go, but we use these new techniques for making the systems autonomous, making the systems self-dependent, making the systems decision driven. Okay.
Sumit, you can ask.
Sir, I really wanted to ask how you get into ISRO and like what inspired you, like about your journey.
See, 30 years back, we don't have any aspirations. Okay, it is only a central government job. To be frank, I don't want to make false statement. Oh, I was enthused. See, at that time, hardly any launch was there. Okay, it is only because I joined the ISRO because it is in my native place.
Okay.
I was working somewhere in Jamshedpur. I got an opportunity that was in the same hometown, in the central government, that to rocket science, very fascinating thing. I have come and joined. That is a fact.
Okay, sir.
But why it was very hard?
Why it was very hard? Very good. This question is good. See, you have landed on the other side of the moon. See, South Pole is not visible. Okay. See, you can do something what you see, but the other side of the moon is not visible where we have landed. That is first answer to you. I'll also extend because you could not answer question. I'll put more answers to that one. So when it is on the other side of the moon, that means that side is exposed to the environment, other universe. That is first point. The second point is because it is on the other side, the temperature variation is also very less because it's not getting exposed to the sun. Of course, it will get exposed to the sun, but for a limited time or limited time. So what happens when the sun is not, extreme conditions are not there? There are deep craters. There is an expectation that the water ice is available in the deep craters. When the water is there, definitely hydrogen and oxygen would be there. There is a chance that we can make colonies and we can make a living what you call ecosystem we can create. That is one reason. The second thing is when it is exposed to the universe, let us say in future you can make a launch pad over there, and you can manufacture satellites using robots. That is called, we call it as in-space manufacturing. That technology is picking up very fast. You make your own rocket there, a small rocket, not like this big rockets, because it need not have to cross the gravity. And you can still do your Mars mission, your Sukrayan, your asteroid explorations with maybe 1/100th of the cost or even less. A small satellite may be enough, propulsion may be enough to cross, because that's what we have been doing. Okay, so these are all the advantages of exploring the other side of the moon. That is the reason many of the countries are interested to explore South Pole and near South Pole. Now interest has increased. Many hundreds of missions. If you see the globe, you can many dots are there. How many missions have thrown to the moon? But southern side, southern pole, many people have not attempted. And ISRO would be, India would be the first successful mission we have carried out, that is Chandrayaan-3. That is why entire world is envy on us today. Why developed nations are envying, putting dirty tariffs. This is not the bigger reason behind that one. They are not able to digest our technological prowess, technological achievements. Okay?
Okay.
Okay.
Good morning, sir. I just want to ask, what are the upcoming missions of ISRO that young students should be excited about?
Okay, see, the routine missions are there. I need not to talk about the commercial and routine missions, but important missions are Gaganyaan is the immediate one, which we have. ISRO has slated for 26 and 27. Then Chandrayaan 4 is a sample return mission, which is again targeted. That's what yesterday chairman was announcing, around 28 or so. The Bharatiya Antariksha Station, we have to put first module into the orbit by 2035, and for that one, the preparations are on. Yesterday in Bharat Mandapam, Delhi, they displaced the model of first module of Bharatiya Antariksha Station. These are all important. Sukryan is another mission which ISRO is working on. There is a LUPEX with Japanese collaboration. There is another moon mission in between. It is going with a big rover, which is contributed by the other country. That is, these are all the important missions which will take place in addition to usual NAVIC. Some missions are there, and some foreign satellites we are launching in this year. So these are all the additional commercial and routine missions, but the interesting missions are these, which are approved.
It is.
Sir, I wanted to ask that Aditya L1 is actually currently exploring the sun, right? So, since we know sun's temperature is a lot, like it's a high temperature thing. So, how is Aditya L1 managing to get all the info of sun from like a close range without getting burnt?
See, we are not putting any satellites closer to the sun. It is at L1 point. Okay, it is very, 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 very far away from the sun. But only thing is, it's an advantageous point, and it is equivalent to any other satellite. But that Lagrangian point 1 is a very crucial point where the satellite will always, most of the time, will be looking at the sun. Okay, and it is any other satellite we make out of thermal insulation is there. Any deep space missions are much harder than this mission. The environment is very confused, very it's not that much harsh. If you go near to the sun, yes, the temperatures are very, very high, but we are not going close to the sun, but we are putting the satellites in an advantageous situation where it will see most of the time. It will not undergo eclipses. It will go in a vintage point where it will be looking at the sun most of the time.
How is the sun burning if there's no oxygen in space?
Beta, sun burning will not happen with oxygen. Beta, sun is a differentiation. It's a fusion. It's a fission. Okay, it is the helium molecules will be broken into hydrogen. That's how the sun burns. Okay, oxygen नहीं चाहिए उसको. ये तो मैच बॉक्स नहीं है. ठीक है.
Yes, Shubham.
Okay, cute.
Shubham.
Good morning, sir.
Good morning.
Sir, I need to ask you about a question about Mangalyaan 2. सर मतलब 11 साल हो गया, अभी तक मंगलयान 2 का कोई अपडेट नहीं मिला सर, पर कब आ सकता है इसका अपडेट? मिल कर सकता है अपडेट सर?
मंगलयान 2 का बारे में अभी होने वाला है बेटा, अभी होने वाला है, because we are tied up with too many activities. Now approval process we have to make it. ये गवर्नमेंट है ना, पैसा चाहिए, इसके लिए बहुत बड़ा प्रोसीजर रहता है. प्रोजेक्ट रिपोर्ट बनाना है, उसको ऑब्जेक्टिव्स बनाना है, पेलोड्स कौन करेगा, कौन एजेंसीज कोलैबोरेशन रहेगा, ये बहुत बड़ा प्रोसेस है. ठीक है, जब अप्रूवल मिल जाता है तभी प्रोजेक्ट शुरुआत हो जाती है. ठीक है, तब तक वेट करना पड़ेगा.
Devanand.
Thank you so much, sir, for exploring the topics so clearly. I have a question related to this. Sir, do you think space research can help solve problems on Earth, climate change and natural disaster?
See, I repeatedly telling you, space technology is an enabler. It will not solve the problems. It will show a way. Okay. So disastrous management is happening. Let's say I'll explain you. If a cyclone is taking a path, let us say there is a cyclone. The cyclones are formed or not will be known through satellite technology. How this satellite cyclone is taking path, because it will not go in a straight path. It will go like this. It will go like this. It will go like this. Like this. It will go. It will take its own route and it will changes its route and position location. Okay, it will alert the ground people where it is going to expect it to be crossed. But when it is giving a direction, when it is giving some kind of indications, the ground system people, they have to evacuate. See, the space technology is not saving the people. The saving the people is done by the government, is done by the local people. But it shows that, look, the space cyclone is going to cross near this coast, near this area. Please evacuate. Similarly, when water floods are happening, hours of ahead, it may give you an indication that, look, there is an upstream water raise, because it may likely to come and floodgates or dams are going to be over flooded. You please release the water ahead so that the upstreaming floods can be accommodated in the storages. Then somebody has to go and open the gates to save the lives. Okay. And similarly, why such kind of disasters are happening, collapse of there is an Uttarakhand mass destruction by cloud burst. There is a why not there is a calamity, because out of that one a village got washed off. These all will happen within no time. There is no way, even if you predict and predict the situation, by the time the local administration is alerted, the damage happens. Okay, so in such cases, even though we know that in couple of hours or couple of minutes it is going to happen, we can't do anything, because it is not we are not gods, just like that. Within 1 second, oh, vanish everything, all the people will be transported, lifted within 1 second and deported. Okay, by the time we know, we give alert messages, by the time the damage will happen. Okay, so space technology only gives an indication, gives a direction, enables different systems, but ultimately the other systems have to act.
As we come towards the close of this session, I would like to extend an heartfelt gratitude towards our chief guest, Mr. Sudheer Kumar-ji, for taking out time from his busy schedule and to be with us on this very special day. Your words have just not informed us, but also inspired all of us to dream bigger. I also thank our institution's management, faculty, and the students for making this event possible. Finally, I thank each one of you for being here today, making it memorable. The sky is not the limit. This is just the beginning. Thank you, and let's continue our journey among the stars. Thank you, everyone. Thank you so much.
Thank you, beta. All the best, all of you. Because it is
Thank you
holiday,
so
I
much,
also
sir.
could spend. This is a holiday, and that too I am in Delhi. I am not in house, so that I could spend a good amount of with you. I am very thankful. Good questions, very good, well organized. Even though initially there are some hiccups, please continue to do so. Thank you. Bye.
Thank you so much. Thank you so much, sir.
Yes.